In this video, I want to talk about spectra, and spectra is the plural of the word spectrum. In this video, we're going to talk about three types of spectrum, and if you look to the image on the screen, you're going to see the three types of spectrum I'm referring to. One is called the continuous spectrum. Two are called atomic spectra. Right? Atomic spectra are also called line spectra, and I put the two words together because it can also be called an atomic line spectrum. Right? So we're looking at 1 and then 2 and 3 together. I'm going to start with image 1, which shows a continuous spectrum. Now, if we take white light, and white light is passed through a prism or a diffraction grating, white light will separate into different colors of light. Now, the different colors of this beam of white light will make up all the colors of visible light. Right? So when these colors of visible light combine, you get white light. And to very easily summarize the colors that we see on the screen, now we're going to see colors such as red, orange, green, well, so I forgot yellow, sorry, green, blue, indigo, violet. So this kind of summarizes the different colors of visible light we will see when white light is separated. Now I'm mentioning some of the colors, but if we look to what is called the continuous spectrum, we are not going to see a distinct color for red and a distinct color for orange, yellow, etc. We say that white light, when separated by a prism, which will show the different colors of visible light, the colors of light appear as bands. Right, so I'm going to insert that word here. It's bands of light. And what I mean by bands of light is that the range of frequencies which correspond to red or orange or even yellow are not necessarily discrete ranges. What that means is the color red will appear in a range of frequencies and as a band of light, right? Meaning that we can have one specific frequency and we can definitely say that that is red light. There can also be another frequency that refers to red light. So, and that these range of frequencies can overlap such that what we will see is bands of light, and this is what we call our continuous spectrum, right? There's no distinction between the colors as they may blend, right? So this is our continuous spectrum, right? Where white light can be separated to show bands of light, which are seen as like a rainbow of overlapping colors. We talk about the continuous spectrum in order to explain what is the discontinuous spectrum. So image 2 and 3 refer to discontinuous spectrum, where we will see lines on these two discontinuous spectrum, either image 2 or 3, where these lines correspond to specific frequencies, right? Versus the continuous spectrum, where a specific frequency may not refer to a specific color. In image 2 and 3, this is what we call a discontinuous spectrum. We see lines, and the lines refer to specific frequencies which are either absorbed or emitted by an atom. So we're going to look at image 2, which is called our emission spectrum. And an emission spectrum shows the frequencies of electromagnetic radiation emitted by an atom, and it is seen as colored lines on a black background. Each line corresponds to a specific frequency. In image 3, we have a absorption spectra, where if an atom or an element is exposed to electromagnetic radiation, it's heated to a high amount of energy or supplied with thermal energy, the atom will absorb specific frequencies of electromagnetic radiation. We will see these specific frequencies as lines, right? And the lines are black lines on a colored background, right? So in an emission spectrum, we have lines seen on a black background, and on an absorption spectrum, since we are supplying a lot of energy, right? Whatever the atom absorbs will appear as black lines on this colored background. So I'm talking about two different types of backgrounds here. And the types of backgrounds and the colors of the lines are meant to distinguish emission versus absorption spectra.